So I'm going to be kind of moving around this slide a little bit, so bear with me and follow along. So here's the definition of an ellipse, and I'm not going to read it. It would sound like Charlie Brown's teacher, so I encourage you to pause the video and read that. All right, now that you're back. So in an ellipse, we would do this really neat activity where I would have two of you come to the board and hold a string between like one finger on one end of the string and another person's finger on another end. And then the string would be sagging down because it would be longer. And then I would stretch the string out and I would draw all the way around. And when I got done, keeping the string stretched the whole time, then what I would have would be an ellipse. Those places where people would have their fingers on the board holding the ends of the string are the foci of the ellipse. So inside of an ellipse, you have 2 points called foci. You've got focus number 1 and focus number 2. So the plural of focus is foci. So what you see here is an illustration of that. So let's say we've got a focus here and a focus there. And pretend that the blue and the green are the string pulled tightly. The points, if you could picture me dragging that all the way around, the points that would be traced out with that create the ellipse. In an ellipse, the sum of the distance from a point on the ellipse to the 2 foci, if you add those 2 distances up, it will always be the same. So you pick a point on the ellipse and you draw a line to one focus and then to the other focus, and you add those 2 lengths up. It will come out to the same number no matter where you are on that ellipse. Okay, so that's how an ellipse is determined. So that, now go back and read the definition of the ellipse and see if that gives it a little bit better context. We can have an ellipse that is flatter, which we would call a horizontal major axis. Think major, main. The main thing that you would see is its flatness. So it has a horizontal major axis. We could also have a taller ellipse, and that would be a vertical major axis. They won't be the same tall and wide, or else they would be a circle, which is really a special type of an ellipse. All right, the horizontal major axis endpoints are called vertices in your text. So if you remember in the previous video how we counted left and right from the center, up and down from the center, wherever the major axis is, whether it's horizontally or vertically, the ends of those, the endpoints, would be the vertices of the ellipse. And then if you had the other axis, whether it be the taller one here or the wider, or the X and Y, left and right here, X, left and right, that's going to be your minor axis endpoints, and it doesn't really have a special name. Okay? Another thing that you need to know is the distance from the center to each focus, each individual focus is C. Now, not C as in center, but C as in C squared equals A squared minus B squared. Now, no, I haven't lost my mind and forgotten the Pythagorean theorem. I encourage you to look in your book to see this development. But A squared and B squared will be the denominators of your ellipse equation. Okay, so I'm going to scroll on down and pull that up. The standard form of an equation of an ellipse centered at HK is given here. All right, and then I've got something about the major axis and minor axis, but that's already been stated. But notice A and B are in the denominators of your fractions that contain the x binomial squared and the y binomial squared. Also notice the ellipses in standard form are always equal to 1. All right, so let me kind of go back. The center will be HK, just like you're used to seeing. A squared and B squared are the denominators, and A is always the larger value. So if A is under Y, then that means your Y direction is longer. You have a major axis that is vertical. If A is under your X term, if the larger number is under your X term, then you have a horizontal major axis. I wouldn't worry too much about A and B. I would just always do, like if you're trying to find a focus situation, it'll always be the bigger denominator minus the smaller denominator. So now we'll look at graphing an ellipse and identify all of these key points and information regarding the ellipse.